Ladies and gentlemen, my name is Irvin, also known as Kuboman. Welcome to CompTIA Network Plus N10-007 certification practice questions. By the way, this has nothing to do with James Bond 007. This just happens to be 007. But sorry, I'm being a little bit silly here. Anyways, this is a practice questions. These are free practice questions you can get from comptia.org/training. So if you go there, these are 100% free, and these are examples of what might show up, but it may not show up on a practice test. The reason I say that is because obviously they don't want to give you answers for the questions, right? You have to study for them. And that's the whole point of this video. I'm going to show you how to study and how to study for these type of exams. There's definitely a lot of crossover between A+, Server+, Network+, and some other ones. And it's good to study for all of them, especially with these free ones that you get. So these are 100% free. You can check them out yourself, or you can just watch my videos. I already made 3 videos. I made for the A+ 220-1001 and also 1002, and I've also made the Server Plus one, which is down here. So and there's definitely a crossover between all of these, and it's good to study all of them, even though they are free. And again, they may not show up on the exam itself, but there's definitely a lot of crossover. There's no way that they can talk about and give you free practice questions that will not benefit you in some way. So even if the question is worded differently, there's a high chance that they might show up on a test. So yeah, it's important to study. I'll put links to all of the ones that I already made. They're really good to watch. So far, they've been very, very popular. People like them. There are thousands and thousands of views. I appreciate that. And speaking of which, if you can, please take 1 second to like this video. I really appreciate it. I want to give a special thank you to all the people that became members of my channel. Thank you so much. It's definitely not necessary in any way, but it does keep me awake as that money goes towards my coffee fund. Thank you so much. I appreciate it. All right, here we go. CompTIA Network Plus N10-007 certification practice questions. Question number 1. A network technician is connecting to a switch to modify the configuration. If you don't know what a switch is, you should say here a network switch, but they assume that you know what a switch is in this context. Basically, it's like your router, like your home router. That can be also considered a switch. And so let's say you are the network technician and you're trying to connect to this switch to modify the configuration. You want to connect to it. You need to connect to it to modify the configuration, right? So this is something you need to do. Problem is DHCP is not enabled on management port. What's going on is that there are a couple of ways of going about this. Sometimes the management port itself on a big switch. Let's do a Google search real quick because I want to show you. Network switch. Not a video game console. That's something else. So we're just going to look at the images. Here's just a typical big switch that you would see in a business environment. In the back of it, not in the front here. Well, sometimes in the front, I suppose, but usually in the back. It can be in the front. Doesn't matter. There's a physical port that you can connect to so you can make changes. You can also do this over the network, given that the system itself is configured properly to begin with. However, the problem is DHCP is not enabled on the management port, whether it's physical connected port or over the network. So DHCP, which is Dynamic Host Configuration Protocol, deals with assigning IP addresses to all the devices that are connected to itself. So DHCP is part of the switch, and the switch itself, you know, the way it looks right now, right? You can see that a bunch of computers are connected to it. It needs to be working in order to assign automatic IP addresses. And here it says DHCP is not enabled. So we cannot, we cannot, at this point, we cannot even connect to it if we're trying to connect to it over the network. So this is a big problem, Dynamic Host Configuration Protocol. And the question here is, which of the following does technician need to configure to connect to the device? As I mentioned, without DHCP enabled, there are no IP addresses assigned because that's what DHCP does. It assigns IP addresses to all the devices that are connected automatically. If it's not enabled, then what do we need to do is basically to connect to this device. So what we need to do is actually get an IP address, which is one of the answers here, the very first answer under A, IP address. So logically speaking, just knowing all these facts, this is what we need. Otherwise, we won't be able to configure or connect to this device or any other devices that connect to that switch. Default gateway, I'm going to talk about all these answers as much as I can. Default gateway usually is an IP address that leads to the outside. So let's say your network switch, let's make it kind of simple here. Let's say this router is your network switch at home. The default gateway on it will be your IP address given to you by the internet provider. So all the things that are connected to here, all of these 8 ports, they will get local IP addresses that are derived from the default gateway, which comes from your modem, from your internet modem that is connected to this switch. Okay, that's very simple to understand. It's a gateway as in a door. You can imagine a door that leads to other networks. And for that, obviously, it's going to be your IP address that's given to you by an internet provider, right? And that's always going to be the case. In some cases, it's going to be different if there's a proxy setup, but I don't want to keep that. That's something else we can talk about later. That's really to proxy and whatnot. In this case, that's what default gateway is, and that's what it is by default. And then under C, it says DNS address. DNS address, domain name service, is basically a server that has the translation of the IP addresses into host names. So let's, for example, talk about like a website like my website. Let's go see here, cosmicnovo.com. Basically, DNS basically tells your computer what the IP address is for cosmicnovo.com. And you can simply just go to command line and type in ping cosmicnovo.com, and it will give you the IP address. You wouldn't know what the IP address is unless the DNS is working, which is not the case here. It could be a problem in some other situations, where you can't reach a website by their host name, meaning or their domain name, I should say. Then the DNS might be an issue, and for that you would need to update the DNS addresses on your computer, but that's not the issue here. And then we have here under D loopback address, which is 127.0.0.1 loopback address. And this is something to expect. It says here loopback address, doesn't say loopback IP address. This is very typical of these type of questions that come up in CompTIA and other companies, I'm sure, that sell certifications, is that it's incomplete. We should say loopback IP address rather than just loopback address. But they're assuming that you already know this stuff, and I'm not. This is why I'm teaching this, everything from basics to on, so it's easy to understand. So loopback IP address is 127.0.0.1, and you basically ping it on your computer to test to see if your network card is working. It's basically to see if your hardware works. That's all it's used for. It gives you, you just type in, try it on your command line, open up and type ping space 127.0.0.1, and then it'll basically give you a reply saying that your network card works. That's all. All right, moving on. Question number 2. An architect designs the building blueprint for a new office. Okay. The new IT team has to purchase equipment and cabling. All right. Upon inspection of the building layout, it discovered that no designation was made for network infrastructure wiring, cabling, and services for the building. So this architect guy, he's designing these blueprints, but he hasn't decided on a good layout, on a building layout, or he hasn't decided on how he's going to go about routing any network wiring, any network cables, nothing. or even to house like switch room or nothing. Which of the following needs to be documented in the blueprint for building connectivity? So we need now we need to help this architect decide what he actually we need to tell him what he needs to do so that way we can connect the network infrastructure, cabling and services for the building. I mean, imagine this is just a bunch of cables that you need to run through the whole building, a bunch of servers, bunch of switches, and all of this stuff has to be routed through somewhere and housed somewhere. There has to be a dedicated room that will house all the switches and servers. All right. So now that we know that, I feel like that's self-explanatory. We need a room to hold all the network equipment, and we also have to keep in mind that the cables need to be routed. HVAC, under HVAC, that's heating and cooling type of stuff. We don't care about that, right? This is not IT stuff. It's funny. It's a funny answer. Don't say that. And then we have a server room. Server room, maybe, but some cases server rooms are kept separate. And matter of fact, in my personal experience, server rooms are kept separate from the switch rooms. It just depends. Sometimes they're both in one, but let's see what kind of other options is. And server room, let's do a quick Google. Why not? I mean, we're just learning here. And here we go, some images. This is what it looks like. This is just a bunch of servers in cabinets, and they're usually just locked, not like open like this. There are usually locks on them. And but you can see that there are some switches underneath. You see that? There are some connections running down there. So this is what I mean. But it all depends. But let's see what other have. And then we have under C, MDF. So if you never heard of MDF, let's Google it. And this is why I really wanted to kind of go about it like this. We got to go through all the answers. MDF looks like somebody already Google is smart. Look what it says here. Suggested based on your recent activity. So you knew that I was looking up some networking stuff. So let's do this. MDF server room. So MDF server room is basically a place where you house all the routers and switches, right? That's all there is to it. And let me see if I can get an image of it. And you see, boy, that's a mess right there. Look at that. Anyways, that's what it is. It's just a room. Usually on every floor there's a room. So let's say there's a building with like 3 floors. Every floor will most likely have an MDF room, which is which is a room that houses all these network switches and cables. Okay, so that's something definitely to consider, right? And then we got mechanical room. Nah, it has nothing to do with networking. So the answer here is, since it gives us only one option, is MDF, right? We need that MDF room. Okay, moving on. Question number 3. A network technician, here we go. It's you again, guys. That's you, network technician, has been notified that an available wireless SSID is using insecure web encryption. Oh, man. No. 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 This is just not acceptable. We don't want anything insecure, right? That's... All right, so you as a network technician have been notified that there is an SSID, wireless SSID, is using insecure WEP encryption. So wireless SSID is a broadcast ID that you see whenever you're searching for wireless. Like let's say you go to a hotspot at like a coffee shop or something, and the name for the wireless is wireless SSID. So that's what that is. This is basically your network name, So SSID, we know what that is now. That's just the network name that comes up whenever we're trying to connect to a wireless. Let's say it says, Irvin's Wi-Fi. That's a SSID, right? And then it's using insecure WEP, web encryption, which is protocol that allows you to connect to the network instead of just physically connecting to it, right? It's wirelessly. That's all that is. And then you can choose which type of connection do you want. Do you want the insecure, meaning there's no password, or do you want the one that's secure? Do you want to set up security? Do you want to set up a password on it? That's basically what they are saying. And you have been asked to investigate whether other options are available on the existing wireless hardware. So kind of going back to connecting to the switch, this is what you would have to do. You would log into it and then see what's available when it comes to wireless connectivity. What kind of security can we set up, right? The technician has found, so you found, that WAPs support AES-CCMP. All right, and we're definitely going to look that up because it's one of those longer acronyms, and then ask you which of the following should the technician configure. What should you change? We already know that the problem is insecure WEP encryption, so we have to make it secure. That's the main thing we're going to do for the available wireless SSID that's insecure right now. So wireless network needs to be configured to be secure. All right, let's look this up. At this point, we don't really have to worry about this. We don't need it to answer this, but I'm going to Google it because it's related to the way the connections are encrypted. So what it is just a type of encryption that it's used. So these are available ciphers, if you will, and it's related to the CCMP part of it is related to cryptography, meaning to encrypt something. But if you look at the basic definition here, CCMP, counter mode cipher blockchaining message authentication code protocol. It's basically saying that you have an option of encrypting. This switch is able to encrypt the connections using these type of ciphering capabilities or protocol, if you will. So that's all that is, and it's just AES-CCMP, and it kind of refers to the length of it. In this case, it's 128-bit. And then let's look at the answers. Under A, it says WPA2. Well, let's see what that is. I know some of you already know this, but bear with me. Again, this is something we're learning together. And you can see already that I've clicked on it before because I talked about it in my other videos for A plus and Server plus, and there's definitely crossover, guys. I don't have to prove this because it just kind of proves itself. And it's a Wi-Fi protected access, right? So this is the system that's a part of your router for the wireless where you can set up the encryption, right? And there are three different versions of it. There's a regular WPA, and then WPA2, and then WPA3. As you can tell, these are all levels of the encryption. How long do you want the password to be, and also how well encrypted do you want it to be. In this case, WPA2 is secure enough, and they are giving us that option. So, we're probably going to consider that as an answer most likely here. And then for B, we have MAC filtering. This is something that I definitely talked about before too. Then we got MAC filtering, and it refers to a security access control method where MAC address assigned to each network cause is used to determine the access to the network. Meaning that, let's say you have, let me go back to our network switch. Let's say you have 8 of these computers connected. You can set it up so that they will not be able to get an IP address unless it's to specific MAC addresses, meaning physical addresses that each network component have. Every computer, let's say, that's connected to this is going to have their own unique MAC address, and the switch will not allow it access to the network, meaning it's not going to give it an IP address unless it has that specific MAC address. This can be set up wirelessly too, but it's an overkill. So we're just going to move on and see what other options we have. And then we got under C, we got MD5. Let's see what MD5 is here. MD5 is a message digest algorithm is widely used hash function production of 128-bit hash values. Although MD, this is we're talking about cryptography hash functions, and this is something that's part of that encryption that's already built into WPA2. So MD5 is type of hash used in the encryption. So this is already part of WPA2. So we don't have to worry about that. And then we got under D, we got WPS. Let's see what that is. WPS just simply means wireless Wi-Fi simple configuration. And what that does is you just press a button and it gives you automatic encryption on it. So it's an easy way, and a lot of like home routers that you will get this, you come with this, you press a button and automatically creates a wireless network for you and encrypts it if needed. This is not what we want to do. We are network technicians, and this is something we want to set up manually. So the answer here is WPA2. We're going to log into the network switch and set up this Wi-Fi wireless SSID to use WPA2 encryption and set up a password for it. That's all there is to it. Question number 4. A technician is called to troubleshoot a client's PC that is not connected to the network. So it's a PC that's not connected to the network. Very simple. Technicians first examines the LEDs on the NIC, network interface card. So it's in the back of your computer where your network cable is, whether it's flashing, right? That's where you're checking to see if it's flashing. Hey, it's a pretty decent way of knowing whether you're connected or not. And connection to the wall jack. What a technician is called, let's go over this, to troubleshoot the client PC that is not connected to the network. Okay, the technician first examines the LEDs on the NIC and the connection to the wall jack. What does the wall jack have to do with the connection of the network interface card? Are they assuming the computer is not connected? This is really weirdly worded, but okay, sure, why not? The technician runs a loopback test on the NIC. So remember when I told you what the loopback test is? It's that 127.0.0.1. So that's what he's doing. And this can also be done with the hardware. It can be done. There's a tester that you plug into the network interface card in the back of your computer where your cable connects to, and it will do the same thing. And then now it's asking us which of the troubleshooting skills is technician demonstrating. So it's asking here, what is he doing? What is this guy doing here? All right, sure. A, he's using inductive reasoning. So these are type of troubleshooting and naming schemes that they're talking about. I'm not a big fan of these, but they do like to use them in educational institutes, schools, I should say. I should have just said school. I don't know why I'm trying to sound fancy here. But its inductive reasoning is a type of logical thinking that involves forming a generalization based on specific instances you've experienced, observations you made, or the facts that you know to be true or false. So it's kind of like using logic to see, trial and error type of thing. And then under B, it talk about OSI model bottom to top. Now we are started to talk about something that's related to IT, right? So let's Google this. The seventh abstract layer of the OSI model can be defined as follows: from top to bottom. So this is they're talking about abstract layers of OSI model. Layer number 1 is the physical layer, right? So physical layer meaning whatever's physically there. For example, the computer itself that he touched, the network, the NIC card that he touched, that's physical layer. And then number 2 is data link layer. We can say that he looked at this by testing the loop with the loopback IP address test, whether it's through CMD or with a tester. And then he's testing, the number 3 is the network layer, which is definitely, that's what he's testing, and then we got the transport layer. These are all related, okay? So that's something to keep in mind. And then we got trial and error. It's kind of the same thing as inductive reasoning, in my opinion, but I think he has a method of testing this, although it's worded really weird. I don't know what the wall jack has to do with this. I guess he's just making sure it's physically connected. I just wish they would word this properly. But if you go to it, if you go through it like this, he makes sure that it's physically connected, it's plugged in, it's powered, and then he looks at the LEDs in the back of the network interface cards to see that it's flashing. You know, they don't say that, but that's what he's checking to see if it's flashing. If it's blinking, that means there's a connection, right? And then if that's not true, then he looks at the loopback test. He does the loopback test on the network interface cards to see if the network interface cards is working, assuming that he doesn't, that first two fail, right? Or assuming that it's properly connected, assuming there's no connection, there's no LED connectivity, he goes for the loopback test. All right. And then asking which of the following troubleshooting skills is the technician demonstrating. And then we got divide and conquer. You know what? I'm not even going to Google this. This because it's not. These are terminologies that can be applied to all kinds of things. The only terminology here, that troubleshooting skill that he's demonstrating here is OSI model, bottom to top. So he's going from the bottom to the top, you know, just like Drake. He's from the bottom to top. And in this case, not to sound facetious, he is demonstrating basically this. He starts at the physical layer, goes to the data link layer, and then to the network layer in order to troubleshoot what the problem is here, and that is the connection to the network. I hope that's clear enough. I apologize on their behalf, really, that this is worded differently, but this is how we go about it, guys. This is how we study for this. All right, question number 5. Users within an office building report wireless connectivity is sporadic. Okay, so sometimes wireless works, sometimes it doesn't. You know, or it's bad signal, this and that. We're just going to assume that it's sometimes working, sometimes not, to make it simple. A wireless technician troubleshooting the issue notices there are multiple WAPs visible in the same hallway within 20 feet or 6 meters of one another. So we talked about WAPs, just the networks, basically. They're basically wireless networks that are visible in the same hallway within 20 feet or 6 meters of one another. Which of the following is causing the issue? All right. So we got multiple networks, multiple wireless networks in the same hallway, close to each other. All right. For A, we got incorrect antenna type. Logically speaking, I'm not even going to Google this. You know, we've seen antennas on Wi-Fi routers, so it's just basically a router, a network switch with an antenna on it. Some of them don't have antennas at all, but it's just an antenna sticking out. Matter of fact, you can just get a coat hanger and stick it in there. It's still going to send a signal. So I'm not worried about that. We got B, interference. Well, we got multiple wireless networks in the same hallway. So yeah, I really think this might be the answer. But I digress. Let's go further. C, frequency mismatch. Nah, I don't think so. Like, you wouldn't need necessarily multiple wireless networks in the same hallway within 6 meters of another. That's just an overkill. If it was frequency mismatch, meaning that wireless network runs on a specific frequency, and you can go inside a switch and change it to a different frequency so it doesn't interfere with other networks. But if you already have a bunch of networks, you don't need, let's say, 5 networks in the same hallway. You know what I mean? You don't need that. So that's not the case here, although it could be a problem, but it's not the case. But if we had let's say, one wireless network, and within let's say, I don't know, 100 feet apart. Let's say 100 feet apart. And there's another 100 feet away. And they kind of, at some point, they meet just a little bit, and they're using the same frequency, there might be an issue there, but it's easily fixed by going into the switch and changing one of the networks to some other frequency, just like one step over or up and down, doesn't matter. Or we got signal reflection, meaning that it's reflecting signals that are, well, this is kind of weird because signal reflection, let's see what this is. This doesn't come up often. Occurs when a signal is transmitted along a transmission medium such as copper cable or an optical cable. Some of the signal power may be reflected back to its origin rather than being carried all the way along the cable for that end. So we're talking about physical connections here, and that it's not the case here. We're talking about the wireless. So we're just going to move on from there, and I'm going to pick what most likely answer here is. That's interference, because we got multiple. And I know a lot of you guys already knew that this was the case, and that's awesome. But we're learning together. We're going to keep learning together, guys. All right. Question number 6. A network technician, again, that's you guys, is tasked with troubleshooting intermittent network connectivity issues within an organization. So I like that the way they're kind of, with the questions that they're doing, it's kind of back to back to back and they're related. I do like that. At least that's how I go about presenting some of my content too, when it comes to like interview questions and answers for the IT positions. So it's easier to learn about. But anyways, a network technician is tasked with troubleshooting intermittent network connectivity. It means it sometimes works, sometimes it doesn't, or sometimes it runs slow, sometimes it runs normal. Whatever it is, we don't know what exactly the cause is, but we know it's intermittent. There's an issue with the network and it's intermittent. Sometimes it works fine, sometimes it doesn't. Which of the following are possible network service issues? And we need to select 2 of them. So what could be wrong, or what could possibly be wrong? So this one is a broader question, more of like just what do you think it would be, just kind of, what is your first thing that comes to mind? In this case, they want 2. So what is your first and second thing that comes to mind that could be causing the issue? And guys, when you think about this, we kind of, in IT, we kind of think like this too, where somebody tells us, hey, there's a problem, can you help me? And then the first thing that comes to your mind, they're like, aha, did you check this? And then the second thing, oh, okay, well, did you check that? So we need 2 of those, just like so. Okay, so there's intermittent network issues, and we're going to go through these together. A, duplicate IP addresses. Well, logically speaking, we don't want duplicate IP addresses on a network, right? That would cause problems. You would have 2 different hosts or computers, if you will, 2 computers trying to use the same IP address. And that's bad. That's just bad in itself. Yeah, this could be a problem, because if one takes the IP address, computer number 1 takes the IP address, and the second one is like, oh, but I want that IP address. So they're kind of fighting for it back and forth. Few minutes, one computer has it, computer number 1 has it, and then suddenly it loses it, and it's grabbed by the other computer, and then the first computer now doesn't have the IP address because it's a duplicate. And this is usually caused by static IP addresses. DHCP, as we talked about, it means dynamic host configuration protocol. That means it dynamically assigns new IP addresses and automatically. So in this case, most likely duplicate IP addresses can only happen if you assign a static IP address. Matter of fact, let's look at this. Yeah, you see here, if you're static IP address for a duplicate address can conflict on a DHCP network. So to resolve, convert the network device with a static IP address to DHCP client. Okay, means that we're gonna go to fix it. You revert back to the dynamic, and then we got phishing. Phishing is whenever you get like email that is trying to fish for your information. It's scam email type of thing, So that's what that is. It's not related to this. MAC filtering, we talked about MAC filtering. And let's see, where do we get it? So it's basically, again, uh, computer are only allowed to connect to that network if the switch itself has a record of their MAC address, which in this case is not the case because we remember we talked about MAC address is unique to every component, to every computer. MAC address is unique. There's not a single, there are no two computers in the world with the same MAC address. So that cannot be the problem here because we're talking about intermittent network connectivity issues. So that's not the problem. We know MAC addresses are unique, even if it's used MAC filtering. And then we got exhausted DHCP scope. So here we go again. This word here, exhausted, is the key word here, and also scope, but not to not to omit DHCP, Dynamic Host Configuration Protocol. Remember, guys, this is the switch that allows all these other networks, all the other networks and other computers to connect to that network. And if there's a limited scope, meaning, there's a limited, usually scope in this case means there's a limited amount of. So we're going to Google this just to kind of, see how you would go about researching this. Exhausting a DHCP scope can sneak up on you, so you may want to implement some IP address management. That's just, where is this from? Oh, this Professor Messer. All right, cool. So basically what happens is you run out of IP addresses on that specific subnet. And that's a problem. That means all the new computers that connect to that subnet are not able to connect because there are no more IP addresses to connect to. This is an issue when you have a large organization and you have to create subnets because each IP range has a limited amount of IP addresses available, and that's the DHCP scope. Once you run out of that, you have to create a subnet in order to create more IP addresses. So if you've exhausted DHCP scope, that's definitely a problem. You got new computers being connected and or trying to connect, and they're not able to because they can't get an IP address. And we got NIC teaming. Well, let's see what that is. So NIC teaming is basically, and this is directly from Microsoft, and that's fine. I like the various sources that we can learn from. Basically allows you to group between 1 and 32 physical Ethernet networks adapters into one. This is not something that we're expected to actually see in this type of example because we're talking about 1 or 32 physical Ethernet network adapters into one. This is definitely not a first thing you would think about as in that's the problem. The other ones are more likely. So this is something you can read up on yourself, and that's fine. But in this case, I wouldn't worry about it because it's very specific to the server configuration that works as a DHCP server. I don't think they're talking about this in this example. And then we got under F, content filtering, meaning that you got a proxy server that's filtering the type of traffic that comes through. It's not a network issue per se. It's more of a proxy server is in a, well, proxy server could be a network issue too, but in this case we're talking about intermittent network connectivity issues. I mean, what's more likely? This is here. We have to pick two that are most likely rather than the one that are less likely. I'm not saying these other ones are not likely, but they are less likely. And I think that's the key to answer in this. So what I would pick is duplicate IP addresses. We don't want duplicate IP addresses. We don't want to make sure that all the computers get an IP addresses because we're talking about intermittent network connectivity issue. And then the other thing that this as likely is exhausted DHCP scope. Okay. Well, I would say less likely, but it's definitely in a second place. So if you run out of IP addresses, that's a big problem. These other ones are less likely, definitely not phishing. MAC filtering, no, definitely not that because, it's based off MAC address. It's all unique. There wouldn't be any connectivity issue when it comes to that. NIC teaming, again, this is more used in a virtualization when it comes to server running a DHCP server, and very unlikely. And then we got content filtering, which usually refers to a proxy server that filters any, that basically allows you to connect to only specific websites and not very specific ones, certain ones. So yeah, duplicate IP addresses, what I would pick, and exhausted DHCP scope. And we can definitely double check these answers later on if you want. Question number 7 here. Which of the following components should be used to manage multiple virtual machines existing on one host? Okay, so we need to pick components that should be used to manage multiple virtual machines existing on one host. So it's one computer or one server, if you will. It's one host, one server, one computer, and it's managing multiple virtual machines. That means it has multiple virtual computers, virtual machines on it that people most likely log into and use it. So you can have, I don't know, let's say 10 people connecting to the server to access a very specific virtual machine, which usually are Windows based. So you have like a mini virtual Windows 10 running, for example, on that server. Okay. And then we have to pick which of the following components should be used to manage. We need to know what's used to set this up. We got number, or I'll keep saying number. It's letter A, hypervisor. Hypervisor is part of Windows virtual machine creator thingy. Isn't that the cop-out way of answering this? So it's a virtual machine monitor, and it's usually used whenever you create virtual machines on a Windows machine, which is called Hyper-V. So this is part of a virtual machine software that's part of Windows operating system that you can use, and it activates this service that runs in the background to basically handle virtual machines or emulation of virtual machines. That's all that is. And then we got a virtual router. Virtual router is unrelated to this. You wouldn't run a virtual router whenever you create virtual machines. Whenever you create a virtual machine on a computer, hypervisor will handle all of this stuff, including creating virtual network interface, any component that's an extension of the hardware that you're using to create these virtual machines on. So let's say it's a server. Once you create a virtual machine, it's just going to extend those. It will create virtual network interface cards on the host machine and on the virtual machine, but it will all virtual. It's not a virtual router. Virtual router would be something that's outside of this machine. So it's not, we don't have to worry about it. This is not local at all. Virtual switch, again, router, switch, it's kind of the same thing. So yeah, no. Virtual network interface card, again, whenever you create a virtual machine, it will create its own virtual network interface card, and it will be an extension of your physical hardware. So it's not something that you would have to pick per se. You just basically make sure that the hypervisor is running, you launch Hyper-V, and then you install your virtual machine. That's all there is to it. So the answer here is hypervisor. Make sure that's running so you can create these virtual machines. That's all. Question number 8. Which of the following is aimed to irreversibly damaging? So what is going to, which one of these things is going to damage and disabling IoT devices? Aha! What is IoT device? All right, guys. If you've never heard about this, let's Google it. It's very interesting. All right. IoT device. Internet of Things. Describes the network of physical objects that are embedded with sensors, softwares, and other technologies for the purpose of connecting, exchanging data with other devices and the systems over the internet. So, Internet of Things. So it describes network of physical object. Right. So, this could be servers, but it could most likely be switches and routers, right? So, which one of the following is aimed to irreversibly damage and disable a network device or a network component, like a physical component? PDoS. What the heck is PDoS? Let's look this up. PDoS. Oh, wow. Bunch of stuff unrelated came to it. All right. Networking. Permanent denial of service attack, also known loosely as P-lashing in some circles. Oh, wow. I didn't know it was also known as P-lashing or plashing. But yeah, it's a permanent denial of service attack. That means somebody is sending attacks to your system so much that it's overflown up to a point where it just kind of burns itself out. Let's say you're trying to send billions of connection requests to a router or a switch or a server, and it's not able to handle that, but then your computer starts to overheat because it's trying to handle all of these requests. That's what that is, a permanent denial of service attack. And yeah, this could definitely damage your computer or hardware. Spoofing. Spoofing is, I'm not even going to Google this because I'm just going to explain it. Spoofing is like when, because you guys are familiar with this, I'm sure. When you get a phone call and it says 1-800 number, but then you answer it and it's a scam, that's because they took that number and they can change it to whatever they want. They're coming from or calling from God knows where, and that 1-800 number is not their number per se. It could be a 1-800 number for, I don't know, for your internet provider. But then you answer it and it's a scam. That's what the spoofing is. They change the number, the number that's calling you to something else. That's called spoofing. Ransomware. Ransomware is whenever your computer is infected with a virus in which it locks your computer completely and they want money to unlock it. That's a really bad virus. It's not irreversibly damaging your computer because it's not like trying to force your computer to, you can remove the virus or you can reimage the computer. It's not irreversibly damaging. It could be irreversibly damaging if you lose like data, like you can't unlock it or something like that. Then that's, that could be considered that. Logic bomb. So let's see what this is. This is also very interesting. So logic bomb is a piece of code that intentionally is inserted into a software system that will set off malicious functions when specific conditions are met. So this is usually hidden in a program that will basically execute this part of that code at a specific time, or a specific time, or a specific function that you do. So let's say you are here's an example. You go to a website and then suddenly you get these weird pop-ups, and there are like a bunch of them, and that's because you clicked something on that website that activated those pop-ups. That's what that is. That's a really good way of comparing it to. But it could be in your software somewhere, and it only activates. It could be malicious. It could be not malicious, but most of the time it is. Well, I mean, I don't know. It could be malicious or not. Doesn't matter. When you do something, click on something, type something, perform some kind of work. But this is the equivalent. The best equivalent I can give you is you go to a website, you click on something, and then a bunch of pop-ups come up. That's a logic bomb as well. That's the way I see it. And then you got under E, MITM. Let's Google this as well, because these are not common things that people talk about in IT and networking. So sometimes even I have to look it up to kind of get a refresh. So it's a man in the middle of attack. It aims to, let's see here. It's a cyber attack where attacker secretly relays and possibly alters the communication between two parties that believe they are directly communicating with each other. Right, so it's kind of spoofing, pretending that you're somebody else. This is not related to networking. This is more of like a social engineering type of issue where they trick you to doing something. So what is it here that mostly applies to irreversibly damaging your device, your IoT device, which again we talked about is Internet of Things. That means anything that's on the network, like your physical network, your physical router, physical server, right? So, and then we found that in this case, PDoS, permanent denial of service attack, is most likely that can cause this damage because it can requires replacement of reinstallation of hardware because it pushes it so much up to a point that it cannot handle the data that's being sent to it. It can't process it. It just overheats and it's permanent damage. So the answer is PDoS, permanent denial of service attack. Question number 9. In troubleshooting network performance issues on a computer, a technician finds that Cat5e cable was run through a conduit with power lines. Oof. Okay. So we're talking about network cable that's Cat5e up to, I want to say 1000 megabits per second. This is like, it's technically gigabit, but it's early version of gigabit, which is, I bet in this case it's irrelevant. It's a network cable that's run through a conduit with power lines. So it's next to power lines. Imagine a network cable run next to the power lines. There is a plenty of spare room in the conduit and cable continuity test is successful. So they're saying there's plenty of room in the conduit and the cable continuity test is successful, meaning that it's working. The cable is fine. Which of the following is most likely issue? So, although there is no problem with testing the cable, right? It's fine. There are still network performance issues on the computer. Logically speaking, you cannot have, it's a bad idea, generally speaking. I'm just going to say this before I even go through the answers. It's a bad idea to run a signal cable next to a high voltage cable, which in this case is power lines, conduit power lines. So let's imagine your network cable is run alongside of your, power cable, which carries in my case 120 volts or whatever, and if you're in Europe 220 or whatever, or to whatever. It's a generally bad idea to do this because of interference. We're talking about electricity, especially high voltage, running next to a Cat5 cable, which is a network cable that carries data. Even if it's shielded, there's a chance of interference. Okay? So, let's look at our possible answers. Attenuation, sorry, English is my second language, believe it or not. So I have trouble pronouncing this one, but let's see what it is. So for this to actually come up correctly to the relation that we're talking about, networking, we have to look for network attenuation. And the definition for that is the loss of signal strength in network cables or connections. This typically is measured in decibels or voltage, and it can occur due to a variety of factors. It may cause signals to become distorted or indiscernible, like radio signals. So this is something that affects the signal strength. In this case, we're not talking about issue where the cable is too long or something is too far for the network connection, and it starts to lose connection simply because of distance. This can happen with physical cables too, as well as wireless cables. So this is not necessarily the cause here, but let's look at the other ones. And then we got crosstalk. Now we are back with networking here. Crosstalk is any phenomena by which a signal transmitted on one circuit or channel or of a transmission system creates an undesired effects in another circuit or a channel. Crosstalk is usually caused by undesired capacitive, inductive, or conductive coupling from one circuit or channel to another. So crosstalk is when there is an issue transmitting signal from one point to another, and there is an overlap in the data being sent. It could be electrical waves that are going through the cables. So that's what crosstalk is. That's how it typically happens. It's just interference on between two different components and electrical components that run on the same type of wavelength. I'm sorry, I don't have a better uh, explanation of this, because this kind of gets into electrical engineer type of stuff, and to be honest, I'm not too familiar with the wavelengths and how electricity wavelengths run through the wires and all of that. But in this case, we're talking about performance issue on a computer, and it may not be related to this. So we're going to definitely um, consider that, but I want to see other answers. Then we have under C, incorrect cable type. We're not even going to Google this or anything or trying to research on it, because all that is we got a network cable run next through power line cables. I mean, as far as we know, these are fine. These are fine wires. These are very fine wires. And sorry, I'm getting tired, guys. It's getting a long video. I apologize, but we're definitely going to go through it all the way. So, as far as we know, there's nothing wrong with Cat5e cable, network cable. There's nothing wrong with the power lines. So we can ignore that. And then we got EMI. Aha! We're getting close to something that might be related. Electromagnetic interference. Aha. So this is exactly what I was kind of thinking whenever I read that. EMI is an electromagnetic interference when you have two different wires running next to each other. Let's kind of read this here. It's also called radio frequency interference. In the radio frequency spectrum is a disturbance generated by external source that affects an electrical circuit by electromagnetic induction, electrostatic coupling, or conduction. The disturbance may cause or degrade the performance of the circuit or even stop it from functioning. And this is why I'm thinking the answer is this, because we have two wires next to each other. One is high voltage, one is low voltage, and the low voltage one carries data, and there are network performance issue on that computer. That's what I think it is. And then we got VLAN misconfiguration. That's virtual LAN. Has nothing to do with this. So in my opinion, the answer here is EMI, and we can definitely double check that. We're going to double check this, because on this one I'm 99% sure, but we're going to scroll down and see what the answer is too. Okay. Question number 10. What is one purpose of network segmentation? Network segmentation meaning to keep something separate or to separate it. Well, okay, let's say you have one super large network, and all these people that are connected to this network, they work in different parts of the company. Let's say one is IT, the other one is business, the third one is HR, the fourth one is, I don't know, let's say collections department, the fifth one is a call center. But what is one purpose of segmentation, meaning to create it into segments, to separate them? Right, to separate them into multiple networks. What is one purpose of that? So pick one. A, protect sensitive data from the rest of the network. Well, that's not bad. B, make file transfers easier for end users. That's already in place. That's what network does. That's already part of the network. That's not part of segmentation. Allow certain services to talk to each other without a choke point. Yeah, network does that. Segmentation could do this too, but we're going to pick one. D, hold all hardened baseline images for deployment. I mean, this is just, if they're talking about baseline images as in Windows images, for example, Windows OS installs, you can put them pretty much anywhere on network. Usually there are copies of it just spread throughout the network on various hosts so they can work, so they can be like a seed, if you will, or kind of, if you guys do torrents, if you guys ever done like torrent downloading and stuff like that, it's kind of like that. But you can do this. This is not part of segmentation, really. This can be basically stored pretty much anywhere on the network. So one purpose of network segmentation is to, and the one the best applies, is protect sensitive data from the rest of the network. So if we're going to separate HR from IT, from uh, collections, from call center, from to whatever business department, this is what's going to happen. It's going to protect sensitive data from the rest of the network. That's the answer. So the one I really kind of want to double check here is, here are the answers here. The one I really kind of want to double check is E. Okay, electromagnetic. Okay. Okay, so I was right on D2. All right, guys. That's it for this video. Please don't forget to like. Let me know if you need more of these. I do see that people responded on my other ones, and people requested this type of videos. And yeah, sure, here you go, guys. I'm making more. Let me know if you want even more, and I'll definitely make more. All right, guys. I hope you have a wonderful day. Good luck. I hope you pass these type of exams. If you find Network Plus to be too hard, consider doing A plus. At least you can. It's a little bit easier than networking. So yeah, I mean, whatever helps you get those jobs, whatever helps you get more money at your company, I highly encourage that you study as much as you can to make sure that you don't waste your money whenever you pay to take these exams. Be careful on the sources that you go through when it comes to learning about this type of stuff. This is why I went to CompTIA website and used their free stuff. Again, if you want to check out my other ones, please do. I have 3 more that are already made. So yeah, that's that. Take care. Bye bye.